Hi everyone, welcome to STEMzebra. My name is Tejas. Today we're going to solve some problems on units, conversion, and SI system. As always, I have these problems in a PDF format in my own handwriting, and they're on our website, www.stemzebra.org. Click on the high school physics tab. I'll put a link down in the description, and you'll find a table there where you can find all this course material and links to videos. So let's get started. Okay, so I have the problems are here and just wanted to show you those before we get started. So I have three main problems, and inside each there are sub-problems. So for example, in the first one, which is about converting the number formats between decimal and scientific. This is one area where I find that a lot of students have trouble once they encounter actual physics problems. So I have some here for your practice. We'll solve those. Then I have a few that are about unit conversion, and then the third problem are more like a word problem and have a little more, few more physical quantities involved there. Okay, so let's get started. The first, okay, go back to this one. The first problem here is about converting number formats. Uh, so I expect you to have a paper and a pencil and a calculator with you. So do all this with me. Go to the website if you want and open that PDF so that you can look at that PDF next to the video, right? Instead of just reading here from the screen. I'll also put all these solutions up, but don't look at the solutions just yet. Okay, try solving these problems yourself first. All right, so uh, the decimal format is this format, right? This is your usual format, how you write numbers. The scientific format, I mentioned it in my theory uh, video, that a scientific format is written like this, where you have a number that's between 1 and less than 10, and it's multiplied by a power of 10. So it makes it easy to manipulate numbers and combine the powers of 10. That's why it's quite often written this way. So I want you to convert these numbers between different formats. Okay, it's a really nice warm up, I feel like, for what's coming up next. So let's get started. Okay, so the first problem here is convert 578.2 to scientific, meaning write it in a scientific format. Remember what I just said. To convert something to a scientific format, you have to make that number between 1 and less than 10, and then multiply it by a power of 10. So how would you do this, right? How would you change this number such that it's between 1 and 10? So you can do it like this. Instead of 578.2, you can write it as 5.782 times 100. So when you do this, you see 100 has two zeros, right? So it's effectively moving this decimal point two places to the right, which will get you the original number. Okay, so when you do this, you get a 100 here, which you should know how to write as a power of 10, which is 5.782 10 to the power Okay, you remember this? We talked about it last time. Uh, 10, uh, 10 to the power 1 is just 10, 10 to the power 2 is 100, 10 to the power 3 is 1000. Don't forget, 10 to the power 0 is just 1. Okay, all right, how about the next one? In these problems, the first set actually, there are no units. Okay, so I just want you to practice the number format, not the unit conversion. Okay, so in this case, it's not like meter or anything, it's just a number. All right, the next one. The next one says convert 3.8 times 10 to the power negative 2. This is in a scientific format, right? Convert this to a decimal format. So decimal is just how you regularly write numbers, right? So 10 to the power negative 2. What is 10 to the power negative 2? Do you remember? Uh, it's not a negative number, right? We did a little bit of that in our theory section. So 10 to the power 2 is, I'll write it on a separate sheet just so that you remember. 10 to the power 2 is 100. 10 to the power negative 2 is 1 divided by 100. All right. So this 10 to the power negative 2 essentially becomes 3.8 multiplied by 1 over 100. Okay, which is what happens when you divide this 3.8 by 100. You have to move this decimal point to the left by 2 places. So you'd move it here once, and you can't really move it here because there's no other number. So instead, you have to add a 0 there. Add meaning you have to place a 0 there. So it becomes 0.038. Okay, you move the decimal point by 1, and then again one more time to the left. So when you did that, you had to place a 0 here, and it became 0.038. All right, very important skill in physics, and actually not just in physics, in engineering, in chemistry. Actually, this kind of calculations, or chemical engineering as well, these come up a lot. All right, the next one is convert 93 divided by 1000 to um, the scientific format, as well as to the decimal format. All right, so I think it's actually easier to write it in decimal first, right? Because that's the more natural way of writing. So in this case, 93 uh, divided by 1000. You know what? It depends on how you look at it. You know, you could say that writing scientific is easier as well because this 1000 is already given to you. Okay, so uh, if you were to let's say write it as scientific first, this would be 93 divided by 1000. Now, what is divided by 1000? It's divided by 10 to the power 3, which is the same as multiplying by 10 to the power negative 3. But this is not the the precise scientific uh, format, right? 93 is greater than 10, so you got to make it less than 10. So to do that, I'll place a decimal point here. I'll make this 93 smaller by a factor of 10, and I'll make this bigger by a factor of 10. Okay, so 93 I make smaller by a factor of 10, which is 9.3. At the same time, I have to make 10 to the power negative 3 bigger by a factor of 10, which is 10 times 10 to the power negative 3. What is 10 times 10 to the power negative 3? It's 10 to the power negative 2 because this negative 3, you're adding 1 to that. All right, so then this becomes 9.3 times 10 to the power negative 2. That's the scientific format. Okay, where's my green pen? Here. All right, but I also want you to do it, convert it to the decimal format, just the usual way of writing. So what do I have here? This is actually very similar to this one, right? To convert to the decimal format. So this is 10 to the power negative 2, which means dividing by 100. So I got to move the decimal point to the left by 2, meaning I had to insert a 0 here. So this is also equal to 0, 0.093. The next one is problem D. I have all the way up to F here. So D says it asks you to convert 897 times 100, actually times 1,000, divided by 10 to the scientific format. Okay, says convert this to the scientific format. How will you do that? Multiply by 1,000 and divide by 10. That's the same as multiplying by 100. So you can write this as 897 multiplied by 100. Now, to convert to scientific, you got to make this 897 smaller. So I'm going to have to divide it by 10. So in other words, I need to account for a factor of 100, right? If I make this 897 smaller by a factor of 100, I need to make this bigger by a factor of 100. So this becomes 8.97 times 100 times this original 100, right? This is the original 100, but that I had to insert another 100 just to take care of the fact that I made this 8.97 instead of 897. All right, so this becomes this 100 is 10 to the power 2. This 100 is also 10 to the power 2. So together they're 10 to the power 4. So this is 8.97 10 to the power 4. All right, that is the answer. That is the scientific format. Okay, everybody with me so far? Hopefully I haven't lost anyone yet. Next one is, so you see I'm making them incrementally more complex, right? I want to start with a simple idea and then I want to make it a little bit more complex so that you can gradually build your skills. Okay, so E is 7 divided by 87 times 10 divided by 1,000. Convert this to the scientific format. Okay, here you'll realize you might need a calculator, right? 7 divided by 87. So 10 divided by 1,000 is equivalent to dividing by 100. Okay, but for now we're not going to worry about that. Let's just take care of the 7 divided by 87. So you can use your calculator to do that. 7 divided by 87. It's 0.08045. So let's say 0.08. Okay, so it's 0.08 times 10 divided by 1,000. So uh, how will you accommodate this into this? So this becomes essentially dividing by 100. So it's 0.08 times 1 divided by 100, right? Which is 0.08 times 10 to the power negative 2. But this is not the right scientific notation, right? Because this 0.08 is not between 1 and 10. So I make it bigger by a factor of 10, but then I also have to make this, you have to incorporate that factor of 10 somewhere. So this becomes 8, sorry, factor of 100. Uh, this becomes 8 multiplied by 10 to the power negative 2, which is due to the fact that I multiplied this 0.08 by 100. 10 to the power negative 2 is like dividing by 100 times this original 10 to the power negative 2. Okay, this is the same as 0.08, and this is the 10 to the power negative 2, which is 8 times 10 to the power negative 4. That's the scientific format. Okay, what's next? Now this is the F. This is the last one of this first problem. It says 10 to the power 5 times 10 to the power 0 times 10 to the power negative 3 times 1 divided by 1 divided by 10. Convert this to decimal. All right. So it's a whole bunch of 10 to the power whatever. So you need to know how to combine 10 to the powers. What is 1 divided by 10? It's 10 to the power negative 1. So I could write this as 10 to the power. Now, when I multiply these things, the 10 to the powers add or subtract depending on the sign. So this becomes 10 to the power 5 times 10 to the power 0 times 10 to the power negative 3 times 10 to the power negative 1. This became 10 to the power negative 1, which is 10 to the power 5 plus 0, 5 plus 0, minus 3 here, minus 1 here, which is 10 to the power 5 plus 0 is 5, minus 3 minus 1 is 1, which is nothing but 10. So that's it. That is the decimal format. Okay, hope you understood this so far. Let's move to the next problem. Okay, so far we have only talked about converting numbers from decimal to scientific, number format. We haven't talked about the unit conversion yet. I did teach how unit conversion works in the theory video. So if you don't remember that, please go check out that video. Here is here are some practice problems for unit conversion. Okay, so here we're going to talk about meter, centimeter, inch, all those kind of fun stuff. It says convert these units. Down here, I have a few problems for you. To do that, use this information. It's given to you that 1 meter equals 100 centimeters. This you might know already, but I have given it as a reference. 1 inch equals 2.54 centimeters, and 1 yard equals 36 inches. So you can use this information and convert these things. So what am I asking you to do? 1 meter square converted to centimeter square. 1 centimeter converted to inch, yard to meter, meter square to inch square, and then I have some combination of meter, inch, and centimeter and express it in yard. So here they're all distances. Okay, so we're only going to talk about distances, but these are really good representatives of uh, the type of unit conversion problems you'll encounter in physics. All right, let's get started then. This is the unit conversion. So problem number 2. First one is convert 1 meter square to centimeters squared. Now, do you remember what I taught in the previous video? Where how do you actually convert to this? The trick to doing unit conversion is to multiply by the correct factor, and the factor needs to be 1. Okay, so I'm going to show you quickly. Uh, Sorry about that. Okay, so I'm going to show you quickly uh, how that works. I've shown already in that previous video, but I'll just remind you here. Okay, so let's say that I want to convert. Um, I know that uh, 1 inch equals 2.54 centimeter. I know that. I'm just using as an example. So that means 1 inch divided by 2.54 centimeter equals 1. Correct? Because we divide both sides by 2.54 centimeter. Also, 2.54 centimeter divided by 1 inch equals 1. Also equals 1, right? This is the reciprocal. So if I want to convert 5 centimeter to inch, how would I do that? I would multiply it by this factor. This equals 1, right? So you can multiply anything by 1 and you'll get the same quantity at the end. So I multiply this by 1 inch divided by 2.54 centimeters. So now what happens is the centimeter, this centimeter here and this centimeter here, numerator and denominator, they get canceled, and what's remaining here is the inch. So this is an inch. And what is this? 5 times 1 divided by 2.54. So 5 times 1, which is just 5, divided by 2.54 inch. And then, of course, you can do 5 divided by 2.54, but that's besides the point, okay? What if I ask you to do 3-inch converted to centimeter? Now I can multiply it by this factor because I want to get rid of inch and incorporate, bring in centimeter. Okay, I want to get rid of inch, bring in centimeter. So the right factor then is this one, 2.54 centimeter divided by 1 inch. Now I can get rid of this inch, and what's remaining here is the centimeter. So this is equal to 3 times 2.54 centimeter. Okay, this is how you do the unit conversion. Now, you have to have the right factor. Okay, the factor of conversion needs to be correct. And that is the real skill involved in solving this problem. So that's what we're going to do. I've created these problems in many different ways so that you can see uh, various ways these things can attack you and how you're gonna solve them. Okay, so let's go to the actual problems. Hopefully you got this. All right, so the first one says convert 1 meter squared to centimeter squared. Now, immediately you realize that, hey, I know the conversion factor uh, between meter and centimeter, and I will write it here. It's given in the problem statement, right? But I'll write it here one more, just for your reference. Um, 1 meter equals 100 centimeter. This is the conversion factor. I have meter square here. So I want to get rid of meter and bring in centimeter. So probably the right factor then is 100 centimeter divided by 1 meter equals 1. That factor should be able to get rid of meter and bring in centimeter. But this is meter square. So it's meter times meter, right? That's the square. So it's 1 meter square, which is essentially 1 meter times 1 meter, right? That's 1 meter squared. I want to get rid of both these meters. So that means I need to have this factor twice, in multiplication twice. So I include it as 100 centimeter divided by meter times 100 centimeter divided by meter. You see, I multiplied it twice because I have two these meters to get rid of. All right, so here I will, let me see if I have a red pen here. Maybe I can use this orange one. So this meter and this meter can cancel those numerator and denominator, this meter and this meter, and what's left here is centimeter squared. So what you have here is 1 times 1. I won't write it here because it's, it's just 1 times 1 times 100 times 100 centimeter squared, which is, by the way, 100 is 10 to the power 2. This 100 is also 10 to the power 2, so it's 10 to the power 4 centimeters squared. Right, so it's going to be 10 to the power 4 centimeters squared, or you can just write it as 10,000 centimeters squared. Right, they're both correct. All right, next one. 1 centimeter to inch. How will you convert that? You need a different conversion factor, right? This won't do here because there's no inch here. You need something that connects centimeter and inch. Okay, so I have it here. I say 1 inch equals 2.54 centimeter. So I'll write it down. 1 inch equals 2.54 centimeters. So what factor should I use? I need something that has centimeter in the denominator and inch in the numerator. So I can use 1 inch divided by 2.54 centimeter equals 1. That is the factor. So let's use that here. 1 centimeter equals 1 centimeter times this factor, which is 1 inch divided by 2.54 centimeter, right? So again, I got rid of this centimeter, and what's left is inch. So this is 1 divided by 2.54 inch, which is 1 divided by 2.54 is 0.39. So that's equals to 0.39 inch. Next one, C. Okay, everybody with me so far? If not, if you feel like you're overwhelmed, maybe pause a little bit, go back, take a look at this again. Hopefully, this is a video, so you can go back and watch it again if you wanted to. All right. Next one says convert 1 yard to meter, M for meter. So I need something that connects yard and meter. Wait a minute. I don't have anything here that connects yard to meter. I have something that connects yard to inch. And then I have something that connects inch to centimeter. And then I have something that connects centimeter to meter. So I don't have a direct yard to meter conversion, but I do have it in a sort of a chain. The chain goes like this: yard to inch, inch to centimeter, centimeter to meter. Can I use that chain? You can use a chain. Yeah, let's do that. That is actually the point of this problem to show how that chain works. So uh, I need something that gets rid of yard and gets me meter. So how can I get rid of yard first? To get rid of yard first, I can use uh, these relations here and say this one, for example. I can get rid of yard and convert it to an inch. So what would that factor be? That factor would be, I'll write it here on the right side. That factor would be 36" divided by 1 yard equals 1. That factor can get rid of yard, but then it gives you an inch. How do you get rid of inch? And then you can get a centimeter. So you can get centimeter by using uh, this, or actually inverse of this. So to get rid of inch, you can use um, 2.54 centimeter divided by 1 inch equals 1. You see, this will get rid of inch. But it'll give you a centimeter. So now you can get rid of centimeter by using the remaining relation, which is 1 meter divided by 100 centimeter equals 1. See, this will get rid of centimeter and give you a meter. All right, so you have done this long complicated thing. How do you actually solve it? You say 1 yard equals, I'll write it here again, 1 yard times this factor, which is 36" divided by 1 yard. All right, so this will get rid of the yard. Then I want to get rid of inch. So 2.54 centimeter divided by 1 inch. Sorry, multiplied by, I need to get rid of the centimeter now. So this one, 1 meter divided by 100 centimeters. You see, now I can get rid of this yard and this yard. Okay, let me use a different color just so that you can see. I can get rid of this inch by this inch, and then I can get rid of this centimeter by this centimeter. And what's left now? Just meter, right? Because everything else got canceled. So I have to do the right calculations. This is 1 times this 36 divided by 1 is just 36 times 2.54 divided by 1, which is just 2.54, times 1 divided by 100. It's 100 meter. Okay, which is, to write it in a bit simpler format, is 36 times 2.54 divided by 100 meters. What is this? Now you can use your calculator and calculate it. So it's 36 times 2.54 divided by 100 is 0.9144, okay, meter. So this is equal to 0.914 meter. There you go. That's how you converted a yard to a meter. So what is bigger, 1 yard or 1 meter? Looking at this, what do you think? See, 1 yard is not quite a meter. It's smaller than a meter, right? So a meter is bigger, right? This is how you can interpret this result. Okay. See, in all of these, you should always, at the end, you should check your calculations. But you should also use your common sense to see if it makes sense. You see, meter square to centimeter square. Meter square is a lot bigger. Centimeter is a lot smaller. So if you convert meter square to centimeter square, you should get a much bigger number, right? And that's how we got this 10,000. How about this? 1 centimeter to an inch. A centimeter is smaller than an inch. So 1 centimeter converted to an inch should be smaller smaller than one, right? So you get 0.39 inch. Same thing, yard to a meter. Yard happens to be smaller than a meter, so uh, that's exactly what you get here. Okay. Uh, all right, we have two more left. Um, D says 1 meter square to inch square. Hey, you can now, I'm sure you can use something we have already done, right? This is not really all that different. Sorry, this is inch square. Okay, 1 meter square to inch square. Um, so you need to get rid of meter and get inch. But how will you do that? You have meter to centimeter and you have centimeter to inch. So I'll have to use two of these convergent factors. Okay, so I'm gonna directly just start writing it because I feel like I've explained this a few times. I think when I start writing it, you should be able to relate it to what I have already written. All right, so 1 meter square is 1 meter times 1 meter. But so I want to get rid of this meter. How will I do that? So I'll just write it again. 1 meter times 1 meter multiplied by, I need something with meter in the denominator. So I can do 100 centimeter divided by 1 meter times, you know what, I'm already regretting writing it on this line. I should have written it on the next line, but that's okay. Uh, so I get centimeter now. So how do I get rid of centimeter? Now I can use this previous convergent factor to get inch instead. But this one, I cannot use this. I have to invert it. Okay, so I can use 1 inch divided by 2.54 centimeter. But remember, I have two of these meters here, right? There's meter times meter. So I need both of these again. So that's why I said I regret writing it on this line, because now I have to repeat this whole thing again. Okay, but I can do a trick. I can say square of this, which is the same as saying multiply by the same thing again. All right, so what am I left with then? Then I have, this meter cancel with this meter, and then the centimeter cancel with this centimeter. So what I have left is 100 multiplied by 1 over 2.54 inch square, which is the same as 100 divided by 2.54 this square inch square, which is 100 divided by 2.54 divided by 2.54 is that 39.3. Square is, where's my square? Square is here. So that's 1,550. Okay. Hopefully you can see it on the calculator. I changed it to dark mode so that the camera can actually read this. 1,550. So this is 1,550 inch square. Does it make sense using our common sense method? Does this number make sense? It makes sense because a meter is much bigger. An inch is a lot smaller compared to an inch. A meter is a lot bigger. So 1 meter square should be a lot of square inch, right? And that's exactly what you got here. I have one problem remaining from the previous set of problems, which is this last one, E, uh, 0.5 meter plus 7 inch plus 5 centimeters. So I'm saying I want to add these distances, but they're in different units. One is in meter, this is in inch, this is in centimeter. How will I do that? And I want to add them and then represent them in yard. Okay, so this is going to involve a bunch of unit conversion. All right, so are you ready for this? Okay, so this is E. 0.5 meter plus 7 inch plus 5 centimeter. What is this in yard? All right. So there are a few different ways you can do this. Okay, you can either convert this to something in the intermediate, like you can convert everything to meter and then add it, and then convert it to yard, or you can directly convert it to yard and then add them. You can do either one. So let's convert each of them to yard first and then add them. Okay, that's, I feel like it'll be a little bit easier to understand, right? So let's convert 0.5 meter to yard. So how will you convert this? You need a factor that changes meter to yard, gets rid of meter and inserts yard. So in our previous problem, we have a bunch of conversion factors given. Do I have anything that's directly relates meter to yard? I don't, but that shouldn't be a problem because in this problem C, we already solved something that relates yard to meter. In that case, it was get rid of yard and get meter. Now we want to get rid of meter and get yard instead. All right, so I need to change meter, but I have what I have is meter to centimeter. So I'll use 100 centimeter divided by 1 meter. Now I need to get out the centimeter, which is this is 1 inch divided by 2.5 for centimeter, and then I need 1 yard divided by 36 inch. So you see, now I did exactly the same thing. Same thing as problem C, where I got rid of this meter, then I got rid of this centimeter, and then lastly, I got rid of this inch. What I'm left with is yard. So that's 0.5 times 100 uh, divided by 2.54 multiplied by 36 in yard, which is 0.5 multiplied by 100, which is just 50, divided by 2.54 divided by 36. So that's 0.546. 546 yard. Okay, does this make sense? Does this answer make sense logically? You see, you started with 0.5 meter. So what you got was in yard, but a little bit bigger than 0.5. That totally makes sense, right? Yard is a little smaller than meter, but it's about the same. So converting half a meter to a yard should give you something that's in yard a little bit bigger than half. Okay, that's exactly what you got. Excuse me. So, all right, that took care of 0.5 meter, right? Next is 7 inch. 7 inch equals 7 inch times, I want to get rid of inch and somehow get to yard. Okay, so I have this one here, inch to yard. So get rid of inch and insert yard. That would be 1 yard divided by 36 inch. Inch goes, what you have here is 7 divided by 36 yard. So that's 7 divided by 36, that is 0.194. 0.194 yard. Does this answer make sense? An inch is a lot smaller than a yard, right? So 6 inch is just about a fifth of a yard. So yeah, that at least logically that makes sense. All right. So we took care of 7 inch. 5 centimeter. How about that? 5 centimeter. I want to convert that to yard again. So that's 5 centimeter multiplied by, I want to get rid of centimeter and get something else. So get rid of centimeter, I can convert it to inch, and then inch I can convert to yard. So the factors there are, to get rid of centimeter, I need 1 inch divided by 2.54 centimeter. And to get rid of inch, I need 1 yard divided by 36 inch. Okay, so the same thing happens here. This centimeter goes, and then this inch goes. What you're left with yard. That's 5 divided by 2.54, and the denominator again 36 yard, which is 5 divided by 2.54 in parentheses in denominator 36. That's 0.0546. Okay, so that's in yard. That's 0.054 yard. Okay, so I got these three now in yards. I got to add them, right, to get the final answer. So the final answer is 0.546 yard plus 0.194 yard plus 0.054 yard. So let's do that. 0.546 plus 0.194 plus 0.054. That's 0.794 yard. this is the final answer. Again, using the common sense logic, does this make sense that this would be a really small number because centimeter is a lot smaller than a yard, okay? So 5 centimeter is, a small fraction of a yard. All right, so that is for problem 2 and all its subproblems. Now let's move to the next one. Moving on to the last problem, which has 3 subproblems. Says it's also about unit conversion. But you'll notice that now I have kilogram, meters, second, time. So there's mass, there's distance, there's time. These three, you remember we said that uh, time, length, and mass, these are probably the most fundamental quantities of all. So mastering these three is really important, and I have now mixed in all of this. In number 2, you only had, now here you only had to deal with, uh, sorry, I'm not sure you can see this, but the previous problem, you only had to deal with distance. Uh, that's because understanding distance conversion is it's quite logical, right? And it's a little more intuitive. Here I have mass and uh, time as well included, okay? And also these quantities are a little more complex, a few more things involved there. But if you follow the progression we have made so far, I think you'll get it, okay? So let's go solve these. Number 3, uh, convert the units. And what's given here? Remember our SI system? What's given here is 1 kilogram, which is in the SI system, equals 1,000 gram, and I write it here as g, right, lowercase g. In the correct scientific notation for gram is g. A lot of people sometimes write gm, or if you buy things in a grocery store, sometimes they'll write gm, but the correct way is just lowercase g. Uh, so 1 kilogram is 1,000 gram, 1 meter is 100 centimeter, which is also equals to 1,000 millimeter. 1 hour is 60 minutes. You know that, right? 1 minute is 60 seconds. Here, 60 seconds. Second is the SI unit. Okay. So using these, convert 1 kilogram meters square divided by second square to gram centimeter square minute square. Okay. All right. So now you have many different uh, things to deal with, right? How will you do it? So that's okay. You have the convergent factors here. So let's get started. First one is convert 1 kilogram meter square second square to gram centimeter square minute square. All right. So now you need to convert kilogram to gram, meter to centimeters twice because it's square, and then second to minute. So what are the right convergent factors? 1 kilogram meter square second square equals 1 kilogram. Now I'm going to write these convergent factors next to their own unit just so that it's easy to read. Okay, so kilogram, the convergent factor you need is kilogram to gram. So you need to divide by some kilogram and multiply by gram. So it's going to be 1,000 gram divided by 1 kilogram. That is the multiplication, that is the convergent factor. Um, this is meter square. So how will you deal with meter square? So it's going to be, the same 1 meter square multiplied by, so meter square is 1 meter square, okay? Meter square multiplied by, I need some factor here that gets rid of meter and gets me centimeter. So that factor is 100 centimeter divided by 1 meter, but square of it because we need it twice, right, to take care of this meter square. How about this second square? Now, this is in the denominator. So far, we didn't deal with any that were in the denominator, but that's okay. That's not that really different. Uh, you have second square, so it's 1 divided by 1 second square. Now you want to get rid of second and introduce minute, but it has to be inverted because the second is in the denominator. So that factor is going to be 60 second divided by, this is minute, so 60 second is 1 minute, right? Square. Okay, so what I did, this factor is such that this second square is canceled by this second in the numerator. Okay, and what you're left with is dividing by a minute square. All right. So if I were to write it in a little more neatly, it'll become like this. So this kilogram is taken care of by this kilogram. This meter square, you cancel it with this meter square, and then this second square is canceled by this second square. What you're left with is 1,000 gram, which is this, times this meter square is gone. So what you have is 100 square centimeter square times this second square is gone. So what you have is 60 square divided by minute square. In other words, uh, this 1,000 is 10 to the power 3, 100 is 10 to the power 2, but square of that is 10 to the power 4. So 10 to the power 4 multiplied by 1,000 is 10 to the power 7. Okay, so 10 to the power 3 times 10 to the power 4, that's 10 to the power 7, times 60 square. Uh, this is going to be in gram centimeter square divided by minute square. Just simplify this a little bit. Here, not sure actually you need a calculator because 60 square is 3,600 times 10 to the power 7, right? 3, 10 to the power 3 times 10 to the power 4 is 10 to the power 7 gram centimeter square divided by minute square. I forgot square here, square. Uh, that's equal to, let's convert this to scientific format, right? This looks really a good candidate for scientific format conversion. So I'm gonna, instead of 3,600, I'm gonna write it as 3.6, and the factor of 1,000, which is 10 to the power 3, I'm gonna combine it with this 10 to the power 7. So 10 to the power 3 times 10 to the power 7 gram centimeter square minute square, which is equal to 3 and 7 is 10 to the power 10. So this is 3.6 times 10 to the power 10 gram centimeter square minute square. Let's use our common sense test again to see if this answer makes sense or not. First thing you'll notice is that this is large, right? This is really large. 10 to the power 10 is, it's 10 zeros, 1 and then 10 zeros. That's a lot of zeros. So does it make sense that it's that much? Like from we started with 1 and ended up with this bigger number. Does it make sense? Uh, the reason it makes sense is because, first of all, you went from kilogram to a gram. So, right? So that is like a gram is a lot smaller. It's 1,000 times smaller, right? And then you went from meter square to centimeter square. Meter and centimeter is a factor of 100. So meter squared to centimeter squared is a factor of 10,000. So you multiplied by 1,000 here, then you multiplied by 10,000 over here, and then from second you went to minute, but that's in the denominator. Okay, so that made the number even bigger. So that's why we ended up with a really big number, because now instead of 1 second, we're measuring this quantity over a minute, and then that's a much bigger number. Okay, so this intuitively or logically, this answer makes sense. The next problem is a word problem. Okay, it says there's a snail. It travels at the speed of 3 centimeters per minute. How many meters does it travel in 2 hours? Okay, so I have mixed in a few things here. Uh, hopefully, while hopefully this will be clear to you as we solve it. Okay, so what I'm asking here is this snail travels at a speed. What is the speed? At 3 centimeter per minute. Okay, how much distance does it travel in 2 hours? But I want that distance in meter. Okay, so there are a few different ways of solving this problem. But let's say that I want to convert this speed from centimeter per minute to meter per hour. That's one way of doing it. And then once I have that, then I can multiply by 2 hours. That'll give me how many meters it travels. Okay. There's another way of doing it. Let's say I know this. I know the speed is 3 centimeter per minute. How many centimeter does it travel in 2 hours? Right. So what is 2 hours? 2 hours in minutes is what? Right. This conversion you can just do directly without any, I mean, even thinking about the conversion factors. Right. You know that 1 hour is 60 minutes. So 2 hours must be 120 minutes. Right? So I'm asking you, okay, how much did it travel in 120 minutes? So if it travels 3 centimeter in a minute, how much does it travel in 120 minutes? Right? It's 3 centimeter per minute multiplied by 120 minute, which is 360 centimeter. Right? Now, this is not a unit conversion problem, right? This is just understanding how, if you travel this much in this much time, how much distance do you total travel in 120 minutes, right? This is actually not a unit conversion problem. This is a unit conversion problem, right? You said 2 hours equals 120 minutes. So the snail at this speed of 3 centimeter per minute in 120 minutes travels 3 times 120, which is 360 centimeter. Now I'm asking you, how much does it travel in meter? Okay, so now you can convert 360 centimeter to a meter. You can use the conversion factor here, or you can directly just look at this and answer it, right? You can say, I know that 100 centimeter is a meter. So 360 centimeters should be what? It's 360 divided by 100, right? Or in other words, 360 centimeter times the conversion factor would be 1 meter divided by 100 centimeter, right? Remember, because 1 meter is 100 centimeter. So then this goes, and what you have left is 3.6 meter. So in 2 hours, it traveled 3.6 meters. Okay. All right. The next one is a spider. Okay. A spider is weaving a web at 5 centimeters per minute. So, how many meter square web does it weave in 1 hour? Okay. This is kind of like this problem, but it's a little more complex because it has squares in it. Okay. So, it weaves a web at the speed. Well, it's not really a speed, right? It's area, 5 centimeters square per minute. It's an area per unit of time, 5 centimeters square per minute. I want to convert it to meter square per hour, because that's what I'm asking, right? How much meter square web does it weave in 1 hour? So uh, to convert this, I need to convert centimeter to meter and minute to hours. Okay, so how will I do that? 5 centimeters square per minute. What are the conversion factors that I need? I need centimeter to meter, square of that, which is 1 meter divided by 100 centimeter square, right? Because the centimeter square, I need to square this times this minute is in the denominator, so I need 60 minute divided by 1 hour, right? So let me show you again. So this centimeter square goes numerator and denominator, centimeter here, and it's square. And then the next one is this minute goes here. So what you're left with is 5 times 60, 5 times 60 divided by 100 square. 100 square. What's the unit? This is now meter square divided by an hour. All right. What is this? 60 times 5 is 300, right? 100 square is 10 to the power 4, 10 to the power 4, right? Meter square per hour. Uh, you can simplify this as 3 times 10 to the power 2 times 10 to the power negative 4. Bring this in the numerator. Meter square per hour, which is 3 times 10 to the power 2 meters square per hour, right? The question asks, how many meter square web does it weave in 1 hour? Okay, well, this is the pace at which it's weaving, right? So the pace is 0.03 meters square per hour. That is the pace. So how much does it weave in 1 hour, right? It's in 1 hour, it'll weave 0.03 meters square. Sorry, I'm gonna move this paper a little bit because it went off the camera. In 1 hour, it's gonna weave 0.03 meters square per hour times 1 hour, right? This was the time. So it weaves 0.03 meter square area of web. So remember, the pace in this unit meter square per hour was this, but in 1 hour, it weaved this much. How about in 2 hours? How much would it weave in 2 hours? Twice of this much, right? How about in 3 hours? It'll be thrice of this much, right? In 10 hours, it's going to be 10 times this much, which is zero point 0.3 meters square. Okay, so you also learned, apart from converting units, you also learned how to relate some of these quantities with each other. Okay, so I hope this was all helpful. Your textbook should have problems that you can solve, and you should definitely solve, because I'll tell you, this happens almost every year that uh, when I teach, the students understand the concepts, but when it when they start solving problems, they encounter, a lot of them encounter this phase where you have to deal with numbers and units and quantities and how to relate them with each other, how to convert them, how to actually manipulate them. It can get very confusing. So it's really important that you pay attention to my previous video, and you do some practice problems and get used to it. If you're used to it, it won't feel as scary. Okay, so that's all I have for today. Thank you for watching. I'll talk to you next time.